Um, if I could call our next panel up that deals with the Green Energy Act to come up to the front. So that's Robert Hornung, Paul Murphy, Norm Fraser, and David Lindsay. We'll get you set up with a name change here, and I'll just do a quick introduction for you, Robert, and then turn you to do the rest of the panelists. I was just told that we should be in by noon. Whatever you like. 15 minutes is okay. Yeah, okay. I would just like to introduce Robert Hornung. And Robert here. Robert is the president of the Canadian Wind Energy Association. He's a BA in political science from Trent University, an MA in political science from the University of Toronto, and an international bachelor from the Lester B. Pearson United World College of the Pacific. And the panel, again, talking about the challenges, the policy challenges associated with the Act, and we've had some dealings with the Wind Energy Association and some of their challenges that they're dealing with it. So I'll turn it over to Robert.
Thank you very much, everyone. I presume you've had a very busy day, given where you are in the schedule, and we will be trying to compress our discussion a little bit here. We're trying to squeeze our hour long into about 45 minutes. Just a little bit more in terms of where I'm coming from. The Canadian Wind Energy Association, we represent about 460 member companies, including wind energy project developers, manufacturers of wind turbines, component suppliers, and a whole range of service providers to the industry, including people who do wind resource assessment, construction firms, etc. The Green Energy Act is something that pretty sure everyone in this room has heard of. You're familiar with it. It's certainly been an intense area of public discussion, and we're very pleased to have here today a very distinguished panel to speak with us about some of the challenges associated with this scale and sort of groundbreaking initiative. I'm going to just take a second to introduce the panelists, starting on my immediate left, Paul Murphy. Paul is the president and CEO of the Independent Electricity System Operator in Ontario. He's worked in the planning and operation of Ontario's electrical system for more than 30 years and in the development of competitive markets for the last 11 years. Previously, as ISO COO, he was instrumental in the design, development, and opening of a competitive wholesale electricity market for Ontario. Next to Paul is David Lindsay. And David is Ontario's Deputy Minister of Energy. He's also been deputy of 3 other ministries: Northern Development, Mines and Forestry, Natural Resources, and Tourism. Earlier appointments included President and CEO of the Association of Colleges of Applied Arts and Technology of Ontario, now known as Ontario Colleges. He was the founding president and CEO of the Ontario Superbuild Corporation, and the president and CEO of the Ontario Jobs and Investment Board. So somebody who's dealt with a few challenges in his career. And last but not least, Norm Fraser. Norm is the CEO of Hydro Ottawa. He's responsible for all of Hydro Ottawa's distribution and customer operations, including distribution planning, system operations, distribution design and construction, field operations, billing, metering, and customer communications. It's more than 30 years of experience in the electricity industry in the areas of power system planning, design, and operations. Before joining Hydro Ottawa in 2000, he held a senior position at Hydro One and its predecessor, Ontario Hydro. I'm assuming this is, oh, there we go. Gee, I didn't have to push any button at all. You engineers really know how to do stuff. Let's go. We thought before we dive into the discussion, we'd do a quick, literally 2-minute overview of the Ontario Green Energy Act. The GEA was a comprehensive legislative initiative which you've heard some of the objectives associated with it to help phase out coal-fired electricity generation in Ontario, to stimulate green energy production and jobs. But fundamentally, it's about renewing the electricity system in the province. The Conference Board of Canada just released a report in the last 2 weeks indicating that it's their analysis that there will be $300 billion of new investment required in electricity generation and infrastructure in Canada over the next 20 years. You've just spent a lot of time talking about the municipal infrastructure deficit. There's an electricity infrastructure deficit. We've been underinvesting in electricity for 20 years. And now it's time to make that up. The Green Energy Act is a comprehensive piece of legislation that was designed to make Ontario a competitive destination for investment in this sector. Has several key components: feed-in tariffs, which in essence are set prices for electricity producers using green energy. And it has additional incentives in place for things like power being produced by First Nations or community organizations. It includes clear commitments to build transmission infrastructure targeted at facilitating the deployment of green energy sources. It worked to streamline permitting and approval processes, trying to avoid duplication or eliminate duplication between provincial and municipal levels, trying to ensure that there was more certainty associated with the permitting process. And finally, it also includes local content requirements with respect to project investment. For wind energy, 25% of the total investment today in a project must be made in Ontario. By 2012, January 1st, it has to go up to 50%. Next slide, please. The Act, from our perspective, has been a big success. It's attracted significant interest and investment from green energy manufacturers and developers. You can see it in the results. In the year 2003, Ontario had 15 megawatts of wind energy. Ontario now has over 1,600 megawatts of wind energy. There's another 2,500 megawatts of wind energy that have been contracted to be built over the next 3 years. That's just wind. There's new initiatives in terms of solar, in terms of hydro, in terms of biomass that are coming forward. And one of the key drivers or initiatives within the Green Energy Act is a program called the Microfit program, which is targeted at providing commercial facilities, homeowners, the opportunity to produce electricity and feed it into the grid. And the response to that has been overwhelming. It's not a few hundred people, it's tens of thousands of people who are stepping up to try and take advantage of that opportunity. And the third set of challenges from an industry perspective relate to policy uncertainty and stability of policy. And that's particularly obviously of interest this year in an election year in Ontario, where uncertainty emerges because you don't know where the election's going to go. We still don't know where all the parties clearly stand with respect to this. That uncertainty increases risk. Risk increases cost. It makes Ontario somewhat less attractive as a place to invest. And how do we manage that in this period? So those are things that we're dealing with, but our panelists are going to take a bit more time, really, to delve into some of the issues that they've had to deal with to try and make this a reality. And I guess I'm just going to start from one end of the table and go to the other. So, Paul, you want to kick it off? Oh, okay, very good. David.
Thanks, Robert. And, good morning, everyone. It's been a wonderful morning so far. I've enjoyed all of the presentations, and the last panel, having spent 4 years as president of Superbuild here in Ontario, that last panel went to a passion of mine, the importance of infrastructure in Ontario. But the session we have today speaks to the importance of engineers working in a public policy environment and the important role of public policy and how engineers have such a critical role to play in that. So thanks to the organizers and Kim and all your team, and thank you for the journal that you prepare. It's a wonderful piece of work and helps to broaden the discussion about the role of engineering and engineering work in the public policy domain. So this is a terrific initiative, and I'm glad to be here and look forward to continuing to support you. For those of you who have not had the wonderful opportunity to read a Canadian humorist, Terry Follis's books, Professor McClintock, his fictional character from the University of Ottawa, engineering professor, becomes a member of Parliament, and they are hilarious. Terry won the Stephen Leacock Award for Humor He won the CBC Canada Reads Award. So if you want to know what it's really like working with politicians and engineers, read his 2 books. They are hilarious. You'll laugh. I promise you, you will laugh out loud when you read them. You'll see yourself in them. I worked with Terry's wife, and I've worked with Terry Follis in political environments. He knows the political side of it, so I laughed out loud on some of the things that bureaucrats and politicians do. And I understand he's coming to speak to one of your conferences. So Terry Follis, remember that name. And September 12th, he's coming. So remember that name and get his books. And everything you heard today will be presented in a humorous way. And I'm not going to be humorous today, so I thought I'd take credit for his book. The Green Energy Act, as Robert said, is an incredibly ambitious and transformational piece of bold leadership on the part of Premier McGuinty and the Government of Ontario in trying to bring clean, green, renewable into our electricity system. Commitment that the government made to get out of coal, the largest contribution to the climate change agenda, greenhouse gas reduction in North America, and start to replace that with other forms of electricity. So it's about broadening our mix of energy production coming into the system, and Paul, I'm sure, will speak more about that. It has other objectives as well. And in the previous panel, they talked about you got to make sure that they get the objectives right and have a clear understanding directionally of what you're trying to accomplish in terms of your objectives as you develop public policy. So while a reliable electricity system is incredibly important, and Paul Murphy and Norm, I know, will speak to that from the local distribution company's perspective, there are other objectives in the Green Energy Act that we shouldn't forget. And it's all of these combination of objectives that are creating some challenges. And it is complex to implement. Electricity, those of you who understand the business better than I do, know that the electricity sector is complex to begin with. Once you start layering on these other public policy objectives, the complexity not just linearly increases, exponentially increases. And that's why we're having some challenges in the implementation, but they are implementation challenges that we can and will overcome. So let me speak to a few of the non-engineering challenges, because I'm bookended by engineers, so I'll speak as the commerce student and the public policy person to some of the business and public policy challenges. One of the very important objectives that you heard the Minister of Innovation speak about this morning was creating the new economy in Ontario. Green-collar jobs is a phrase you've heard of, innovation, and the Innovation Minister Murray has been a champion of this, and it's something that's incredibly important in making sure Ontario has a place in the global economy. So bringing new forms of manufacturing and new forms of investment in innovation was one of the objectives of the Green Energy Act. So we have a very generous feed-in tariff program to attract people to come and invest, not just because it's good for the environment and bringing green energy production, but to bring investment for manufacturing and bring investment in new and innovative technologies. So that's a public policy objective that we shouldn't forget as we go forward. I'm conscious of time. I won't dive into the details. Hopefully, as we get into the panel discussion and maybe into some Q&A, I'll dig deeper into that. But my purpose in the first 3 or 4 minutes here is just to remind you of the complexity of public policy objectives we have, not just the complexity of the engineering of the electricity system. Paul will do that, and Norm will do that very well, I'm sure. A second objective, which is proving to be challenging for us inside government and for our private sector partners and developers who are out there, is the government is committed to helping our First Nations community. As Canadians and people of Ontario, we have not got a good record with our First Nations people. I remember the former Ambassador Stephen Lewis, when he talked about the terrible situation of AIDS in Africa and all of the issues that he was trying to bring to the attention of the world at the United Nations. And he was trying to get countries to commit to help with some of those terrible tragedies around the world. They would, his words, not mine, throw our Aboriginal record in our face. So the Government of Ontario has put adders into the feed-in tariff program to encourage private sector to partner with our First Nations to have economic opportunity in developing the green energy in the province of Ontario and partnering with First Nations. Part of the challenges is in that public policy objective is something we refer to very diplomatically inside the public service as capacity challenges. There is not a sophisticated business community inside our First Nations. Some of the chiefs are very sophisticated and very good at what they do, but many do not have a robust business background, and they depend on lawyers and advisors and consultants, and then they have to go back to their band council and get approvals of processes, and it takes a long, long time. So the laudable goal of helping our First Nations to get a leg up and take advantage of this new economy and this new opportunity is a terrific goal. The challenge is in the implementation. A third piece, and conscious of our time, I won't spend a lot of time on it, but before I came to the Ministry of Energy, I was in the Ministry of Natural Resources. And another objective of the Government of Ontario is to protect and preserve our environment. And so when the Minister of Energy at the time wanted to create the Green Energy Act, wanted to streamline and make more efficient all of our approvals processes, again, a very laudable and noble goal. Time is money. I get that. Having spent 4 years running Superbuild, I know the challenges of approvals. But the government's also committed to the Endangered Species Act. It's committed to preserving sensitive lands, environmental initiatives. All of those other approvals were not eliminated. It was supposed to be made more streamlined and more effective. A 6-month guarantee was the phrase in the speeches. But the assumption was the developer would bring all of their materials forward and they would be vetted and approved within 6 months. If you have a wind farm, for example, that happens to be on a bird flight path or a bat migration path, the bats only migrate in the month of May. You submit your application in, let's say, June or July. You can't even do a study on the bats until next May. All of our bat experts are incredibly busy right now. For some unknown reason, there seems to be a lot of people wanting to do bat studies. So there's a shortage of bat experts. You think engineers are underappreciated. You should be a bat expert. There's a shortage of bat experts. So some of those who are hanging their shingle out claiming to be salamander experts or endangered species experts, not so much. They don't have an iron ring. They don't have qualifications. And then when the report comes in, it is less than optimal. Staff send it back. The 6-month clock doesn't start. It's the dumb bureaucrats are taking too long to approve this 2-page piece of paper that says there's no bats in southwestern Ontario, when the biologist in southwestern Ontario knows damn fine there are bats there. So that's part of the implementation challenges from my old days in M&R. So as the Deputy of Energy, I'm quite frustrated. As the Deputy responsible for protecting endangered species, I have a different opinion. That's some of the implementation challenges that we're facing inside government, let alone the financing challenges, the development risk challenges that investors have in an election year. Robert raised that point, and I understand that and agree with that completely. As a neutral professional public servant, I have no opinion on that. But I understand that the challenges are not just engineering challenges. There's lots of public policy challenges. But if it was easy, it would have been done by now. This is the right public policy. It's what we need to do, and we need your help to figure out how to do it optimally for all of the objectives we have in Ontario, not just our energy efficiency.
I had no idea we were going to be talking about bat experts today. Thanks to Ocepp for this opportunity to talk to my peers that are interested in public policy, and certainly the Green Energy and Green Economy Act is an important piece of public policy. My organization directs the operation of the bulk power system to reliably and efficiently orchestrate the resources that we have available to balance demand and supply at every moment in time. And we do this through an electricity market that ensures that it happens efficiently. If engineering is the invisible profession, I guess my company is probably an invisible company, except during blackouts when people tend to take a little bit more notice. And while we advise on a variety of policy matters to government, our main role is really implementing the policy of government once it's developed. And certainly the Green Energy and Green Economy Act is transforming the power system in a very fundamental way. I view it as the largest transformation ever. If we think back to another major policy direction that the Ontario electricity sector took, the Ontario government took with respect to the electricity sector, the move to nuclear. There was 14,000 megawatts of nuclear generation built over a period of 20 years from the early 70s to the early 90s. And if we look at what's being done now under this act, we're shutting down the coal plant, 6,500 megawatts, a quarter of the capacity, replacing it with gas largely, bringing on 11,000 megawatts of renewable generation, largely wind and solar generation, and we're moving our empowering consumers through new technology to be able to do things that they've never been able to do before. And we're doing this really over a space of about 10 years when I think of 2008 to 2008 and 18. So it's a huge, huge change. And we are involved my organization is involved in these various aspects of the coal shutdown and the renewable integration and the smart grid aspects, but I'm only going to focus on the renewables today. It's really exciting when you're integrating a new technology into the business from an engineering perspective. But there are some challenges with renewables, to be certain. For one thing, they're variable. Their output is variable. It changes with the fuel availability, and frankly, the existing owners' ability to forecast what their production output is going to be has not been particularly good. Another challenge is that these resources are distributed. We're used to dealing with large, centralized, big nuclear facilities, coal facilities, whatever. These new facilities are distributed. They're small, they're located all over the place, and a lot of them are being located on the distribution system where we've never had very much generation before, and where we, in our organization, have never actually had the need to look into the distribution system. And the third challenge is that sometimes these resources are available when we don't need them, when we already have enough other generating sources available to us, and sometimes it's where we don't need them because the transmission areas are congested, just like highways get congested. So these are some of the challenges that we're dealing with, and to do this, we've launched something we refer to as the Renewable Integration Initiative. It's got a number of components, but really there's three things that we're really trying to achieve to help us be able to integrate renewable generation. One is to centralize the forecasting as opposed to having it distributed at all of the different producers of these variable resources so that we can get a better idea of what's coming, because if we know what's coming, we can better prepare for it in terms of organizing the rest of the power system. We need visibility, better visibility and monitoring at the local level. As I said, we never had to look into the distribution level before, but we'd never anticipated generation actually coming out of the distribution system onto the system. And we can't operate a system properly and do our job blind to that, so we need better visibility, and that means additional investment in some of the things that these generators would otherwise not invest in. And thirdly, and perhaps most importantly from my view, we need to be able to dispatch these resources. As we get more and more of these renewable generating resources, they are essentially becoming mainstream resources. We still talk to them about alternative energy. It's not alternative energy anymore. This is mainstream energy. And we need to start thinking about them like that and start treating them like that as well. Now, some of these we have to be able to turn these devices up and down just like other generators. Now, some of these, dealing with some of these issues involve largely technical issues, but some of them are policy issues as well, like when you are going to turn something down and you've got a choice between a whole bunch of very low-cost, non-carbon producing resources, whether it's nuclear, water, wind, what do you do first? And the approach that we'd taken to developing our principles for these kinds of questions was to stakeholder broadly within the industry. And one of the things that we've learned, if there's a lesson that I've learned in trying to influence things, is that if you have a consensus among a broad group of stakeholders, you're far more likely to be able to get your message across and have it more readily accepted. But through this process, I've also learned another lesson, and actually I'm still learning this lesson, I guess, and that is that engineering reality is not political reality. I think of this as kind of my Star Trek moment when I get in these conversations, and it's like the crew of the Enterprise encountering an alternate reality. And unfortunately, when I get in these conversations, I can't get Scotty to beam me up. But you know, we in my organization, we've got over 200 engineers, and their technical capability is top-notch. We do really, really good stuff. But what we're not so good at is bridging this gap between the engineering reality, the engineering message, and the political reality, and putting it in terms that, that it can be understood politically. And that's where we often will turn to David and his staff, who understand enough about our business and certainly understand the political side of the business to try and bridge that gap. It's extremely important to be able to do that. And the third lesson that I'm learning is that timing is very important. You can have the right answer or right solution, and you can be prepared to express it in ways that can be understood and accepted politically, but doing it at the right time is important, because there is timing. There are times when things are possible and when they're not possible within the political cycle. And I'll just throw out one example where I thought we did all of these things particularly well, and it was something that Norm Fraser and I were both involved with, and that was with respect to the smart grid. And we formed a broad coalition of industry sectors to look at the benefits that's modernizing the grid could bring to consumers, and we expressed it in terms that you could talk to the political folks about, in terms of the benefits for customers, the benefits for the economy. And in that case, we managed to get the timing right during the development of the Green Energy Act and the policy, the province's policy of adopting smart grid as a policy of the province was worked into that legislation, which is really important. So if we'd had that same idea too late, it still would have been a great idea, but it wouldn't have gone anywhere. So the notion of sort of broad coalitions, talking in terms that matches engineering reality with political reality, and getting the timing right are three things that I've learned and I'll leave you with. Thank you.
Good morning, everyone. I'm going to speak from the point of view of the front line. Now, we, in the local distribution company community, we are the ones that send out the bills to the customers, who are the ones that ultimately are paying for all of this. But before I do that, I'd like to add my own little commentary. I'm a bit of a cheerleader for the electrical industry, and I would congratulate the province for taking the bold move on the Green Energy Act and endorsing smart grid principles. These are not easy decisions to make. Electricity is ubiquitous, it's everywhere, and it's a difficult file to manage, so I congratulate them. I'm going to provide some context on how the Green Energy Act has influenced us and other utilities like us, and how it's changed the landscape for us. Your electrical industry in this province is changing dramatically, and I would say it's changing more dramatically than a lot of other jurisdictions. We talked about infrastructure. Imagine our world and our economy and our lifestyles without electricity on a regular basis. You can have all the lousy roads in the world, but if you can't pump gas into your car, it doesn't make it's pointless, it doesn't matter. Water is very important, but if you can't pump water to your house, it's not as crucial as having that electricity. It's the ultimate perishable product. It must be produced when it's consumed, and it must be managed by the folks in Paul's group, and it must be managed carefully. So your utilities are working very hard to ensure that this actually happens. Let me tell you about some of the other challenges that are going on top of the Green Energy Act. Now, the Green Energy Act is very important. It adds a veneer to everything we do, and I contend that it will probably also provide opportunities for us to get through some of the other challenges we have. In no particular order, customers. Our customer relationship is changing. Our customer expectations are increasing. Everybody in this room and everybody you probably know, with some exceptions, has a personal internet presence that they carry around with them at all times. That's done a couple of things. That's the obvious thing is that it makes them more reliable and more demanding of continuous service, whether it's communications or electricity. But what it's also done is it's changed their notion of their service providers. They need instant feedback. They expect instant gratification. This is a lot different than as recently as 10 years ago. At the same time, our relationship with our customers is changing dramatically. We are getting closer to them. And that's through various things like the smart grid initiatives. But even a basic thing that's happening in the province right now is the rollout of time of use rates. our grandparents paid their bill the same way that most of you and I do right now, unless you're already on time of use rates. We read the meter 6 times a year or so, and sometimes we didn't. Sometimes we just estimated the bill. We'd mail you a bill, and you'd mail us a check. Right now, everybody has a smart meter, or most of us do. Those meters are read once an hour. In Ottawa alone, our 1/3 of a million meters are read collectively 2.6 billion times a year. And I'm told that collectively in Ontario, that's more electronic traffic than the banks. So the very nature of how we manage our customer relationships has changed dramatically. Yes, I mentioned electrical infrastructure is aging. We spend at Hydro Ottawa about $50,000 an hour on our capital program, and we are 7% of the province. So if you want to do the math, you can figure out how much the electrical industry should be spending on their infrastructure. And that's just to keep ahead of the aging curve. In Ottawa, we have 200 large power transformers in our substations, and half of them are more than 40 years old. Based on failure rates, we have to replace 4 a year, and we are replacing about 3. So clearly, we're not spending enough in that particular area. So aging infrastructure is not limited to other types of infrastructure. It's really an important issue for electricity. At the same time, as our capital programs are going up and our infrastructure is aging, our workforce is retiring. So in our particular company, and we're not unusual, 70% of my lines trades will be retired by 2020. And it takes 5 years to train a new lineman. So we, clearly with that's, you've got to hire, I have to hire all of those people in advance of those people retiring, because there is no market right now it's a seller's market for this kind of labor. The same thing with my engineers. My directors and senior managers that run the company are mostly ready to retire as well. Costs and prices are on the rise. Copper is $5 a pound now. It used to be $1.50, and rates are going up. And whether or not the relationship with our customers and their increased requirement for or their expectations on us are going to be conflicted with those rate increases. The Green Energy Act is requiring us to be smarter, greener, and more dispersed. The smart devices in our power system are becoming ubiquitous. They are cheap, they are flexible, and they do a lot more than we ever imagined they would as recently as 10 years ago. And all of that combined is going to require that the employees that we hope we can hire to replace the ones that are retiring have to have new skills. We used to hire electricians who did wiring in substations. They now are computer programmers. The software in all the devices comes with the device, and they have to program them. They don't even need wiring because they're plug and play. So what I'm getting at here is the Green Energy Act adds very interesting complexity, but it also adds a great opportunity. It's a veneer on top of our other problems or other challenges. But I would contend that your utility industry is up for it. What we have to be is we have to be aware of it, we have to be nimble, and we have to make sure we have the right expertise and lots of it. And just to close, one of the things I do not want to see anymore is what I saw a couple of days ago. My cab driver in Ottawa was a laid-off Nortel electrical engineer looking for work. I don't want to see that anymore. Thank you.
Can I just have a quick show of hands how many people might want to ask questions? Help me manage this going forward. Okay, thank you. So before opening up the floor then, just a couple of questions really for the panelists. You've just heard a lot about some of the challenges and challenges of public policy trying to meet multiple objectives, challenges from an engineering perspective trying to integrate some of these variable sources, challenges within the context of the broader electricity system and being faced in terms of the workforce and everything else. So everybody agrees this is ambitious, everybody agrees there's a lot of work to do, but I think everybody also agrees that there are some really important opportunities here, and Norm hinted at that a little bit. And I guess I wanted to give, just a couple minutes maybe for everybody to just offer their reflections on what are some of the opportunities associated with doing this? How is this going to make things better from within the perspective of your responsibilities and what you're doing? And maybe, Norm, I'll start with you.
Well, I talked about how equipment is becoming smarter and we're deploying distributed resources. I see no reason why our planners can't be a little more creative and focus some of these resources and clever devices in areas where infrastructure is starting to fail. My challenge to my staff is, are there asset classes that you could allow to run to failure that you would normally replace if you had more smarter devices, more dispersed devices in your system? So it's not, there are interesting trade-offs and opportunities.
There's a couple of things that I think are really opened up as opportunities. One is, as an industry, it's actually, from our side of the industry anyway, it's actually forced us to open our eyes and think a little bit more broadly about the way that we conduct our business. One of the ways this shows up is really thinking about the role of the consumer in the future, fundamentally different than the past. The consumer as a generator, the consumer as the owner of a mobile storage device when they get an electric car. The consumer with an ability through smarter technology, smarter awareness, and the right price signals to actually respond to the electricity system demands in a way that they never have before. So there are services that we need to reliably operate the power system that have always been provided by generators that can be provided by consumers. And I think what the Green Energy and Green Economy Act has forced us to do is start to think about some of those things. And that opens up all kinds of new innovative ways of thinking of things. We've got a part of our Smart Grid Forum that Norm and I are on has the Corporate Partners Group. These are the private sector group. There's 40 members of that, and they're all just people with wonderful ideas looking for the opportunities to be able to take advantage of this. The other thing that I think is a real opportunity, and it's not much to do with my area of expertise, but I think it actually allows us to sensibly electrify a transportation sector in the future when you can rely on an electric grid that's clean. It makes a lot less sense if you're burning coal and say we want to electrify transportation, but a lot of the good things we can do for the environment will show up not just from the electric sector, but from the transportation sector in the future as well. And again, huge opportunities there.
I'm conscious of the time. I'll build on Paul and Norm's comments and turn it into an economic development opportunity. So all of the investments we've got to make, I spoke to the Smart Grid Forum, 3 weeks ago we were together. All the investments that all of our local distribution companies and Hydro One are investing in are leading edge. The 4.5 million smart meters that Norm mentioned and the 2 million customers on time of use rates is the largest test bed definitely in North America, if not in the world. We are on the leading edge. Some who are saying that we're having challenges have told me it's the bleeding edge, but I think we are on the leading edge. In business and investment, you call that early adopter advantage. And so far, our economic development conversation about the electricity sector has been about solar and wind manufacturing. And Robert and the people he represents are making a great contribution to bring investment attraction to this province. But solar and wind manufacturing is only one part of it. Solar and wind manufacturing, I think we need to start turning our attention from the domestic market to how do we help those manufacturers who we have attracted to come here to start exporting. We only need so much wind and solar technology here in Ontario, but there's other states that are behind us, but will be catching up. How do we grab that? The next piece is the smart grid. Think about the telecom industry in the 1970s, when they went from analog to digital, when we went from the black rotary dial 500 that you used to have at home to cellular technology and all of the new devices that you have on your hip pockets right now. That started in the 1970s. They broke up the baby bells and new technology came along. There were two companies. One, a forestry company from Norway called Nokia. The other, a supplier to the railway industry in Sweden called Ericsson. Because the Scandinavian countries were the first to adopt a roaming technology, They were the early adopters. When the American market opened up for telecom, Nokia and Ericsson were poised to take advantage of that American market. So the next economic development opportunity I think we've got to think about is who are the Nokias and who are the Ericssons in the energy sector that are supplying Norm and supplying Hydro One and supplying Toronto Hydro right now. How do we help them become international leaders? We're at the leading edge of early technology adoption. How do we grab that economic advantage? That's, I think, a big opportunity and a big challenge for us.
Thank you very much. That was very, very informative. I think one more question before we open it up, just in terms of the, in the public discussion that you hear around the Green Energy Act, I mean, one of the main concerns that are brought forward is the impact of the Green Energy Act on costs. It's been mentioned already by the panel, electricity prices are something that are particularly sensitive from a political perspective, but also in terms of ability to compete on an industrial basis, ability for homeowners to make ends meet, all the rest of that. And I guess, what's your perspective on this? Are the price increases that are associated, that we're seeing right now and will see presumably going into the future, to what extent are they a product of investments in green energy and the initiatives here, or what extent would they have happened under any scenario? And I'll start this time from this end of the table. Paul.
Well, I mean, if you were to start from the assumption that there was no Green Energy Act and associated policy, so there was going to be no coal shutdown, no conservation, no renewables, no grid modernization, then sure, the short-term prices could be lower. You'd be using the existing assets, not making the reinvestment, but it would be short-term. I mean, at some point, you've got to make these investments, and of course, there's all kinds of environmental, social costs that are not acknowledged in the way that we traditionally priced electricity. So in the longer term, you're still going to need to modernize the grid. You're still going to need new generation. You wouldn't have conservation, so your demand would be growing faster, and you would need to provide new supply to be able to do that. And new supply is expensive. It doesn't matter what kind of new supply you look at. The new supply that we're acquiring right now is wind and solar, and it's expensive. But any new supply is expensive, whether it's nuclear, whether it's new gas plants, whether it's new hydroelectric development. There are large costs associated with new electric infrastructure, and we shouldn't fool ourselves that there aren't.
Norm went down the list of all the things he's got to invest in Ottawa Hydro, and I won't speak to those, but in the province-wide system, we've got about $87 billion of additional investment still needs to happen. We've got to refurbish our nukes. We've got to build 2 new nukes. We've got additional gas-fired plants to come online. We've got 5 major transmission lines to go in. So Paul's exactly right. There's lots of investment that has to happen in the electricity system, regardless of the Green Energy Act. We have assumed, again, our guys that do the econometric analysis have assumed about 40% of the costs that we've seen so far are attributable to green renewables. But over the 20-year cycle, we're looking at about a 46% increase. It works out to roughly 3% a year, which is not unreasonable if you've got to reinvest in your entire system over that 20 years. So if you smooth it out over the life cycle, it's not an unrealistic increase. We've had 10-year freeze on electricity rates. We didn't raise rates for 10 years, and we didn't make investments for 10 years. The government invested $8 billion in transmission, $7 billion in transmission, and about $12 billion in generating already. So we got about $20 billion of investments have gone into the system. Not all of that's green energy. I'm repeating Paul's point. There's a lot that's gone into just upgrading and refurbishing what we've already got. However, the government recognized that the first couple of years there's a heavy load investment. Over 20 years it smooths out, but in the front end it's a heavy load investment because we've got a decade of underinvestment. So they brought in, for a moment in time, 5 years, the 10% rebate to allow the smoothing at the front end, and the expenditure will be smoothed out over the whole 20-year period. So there's political heat right now, but the prices going up was going to have to happen anyway, and the government's tried to smooth that out as best they can.
I don't have much to add other than the average residential bill per month in this province for 800 kilowatt hours of consumption is about $120, $125. And I did I did confess earlier that I'm a cheerleader for the industry. So in my personal view, that's good value for the money, but I always think, what would be the cost of not having it? So in my view, it is value. Thank you.
Okay, could I get a couple of questions from the audience, please?
I'm just curious because I hear all the time about, skilled professionals driving taxis. And obviously we gain something through experience as we go and we become good at something. And so is it really that, the people who have the skills we need, we're importing them from India? Or are we looking at the people who are on the ground and saying, how do we make use of these people? Like you say you need engineers. How are you going to take this Nortel engineer and utilize them? Because otherwise we've got, like what you were talking about, Deputy Minister Lindsay, was, the whole bat problem. Well, I've seen that within the engineering. You passed this legislation that every building had to have an asbestos report. Suddenly we have companies coming out our ears who do asbestos reports, and now none of them answer the phone because they're not there. So then we have all these people with asbestos. Like, what's happening to them? We're not managing our people very well.
Can I try that one? Yeah, I'll start that one. I'm fortunate enough to chair a not-for-profit called the Electricity Sector Council. It's a federal organization looking into how we can improve the labor workforce in our industry. There are about 125,000 people across this country involved in the electricity business, and in about 6 years, about 25,000 will be short that many because of retirements. So we have a lot of things going on in there, and your sector is looking into this, things like foreign credential recognition, things like transfer of skills from one area to another. So things are being done, and I think you'll find that it's starting to accelerate. There are more and more lines trade schools being set up in colleges, and some of the universities are reinvigorating their power engineering faculties. I know Carleton is doing that. So it's starting to happen, and the message is getting out that these things must be done. So I'm optimistic, I'm hopeful that that's going to get some traction.
I see there's a lineup at the microphone, so I won't take too long, but this is something that, an excellent question that I've heard the Premier speak with passion on a number of times. After I left Superbuild, I went to the Colleges Association for a couple of years, and making sure we have training opportunities for new Canadians. There are some challenges, as Norm says, about credentialism, so I throw the challenge back to the professional engineers to talk about how you can help accreditations for foreign-trained professionals. The college in training technicians, it's quite often a language issue. Learning the technical language of engineering language for technicians in Ontario, if you're coming from India or Romania or a different country, the colleges have been giving targeted programs for upgrading their gaps as opposed to making them take a whole new engineering degree. A decade ago or 15 years ago, we used to say, well, you had to come and get your engineering degree in Ontario. And now we're saying we'll help identify the gaps you have. It may be a language, it may be a particular technical aspect, and we'll try and fill that gap. So we were quite blunt in our instruments 30 years ago. We brought labor after World War II to build our roads and highways. And the Portuguese and the Italian immigration of the 1940s, late 40s and early 50s built this infrastructure. And language was not so much an issue. Skills was bricklayers and physical labor. Now we're inviting people to come because of their academic training, and then when they get here, their credentials aren't recognized. So there's a credentialism and a language barrier, and that's all of our responsibility.
I've been informed that we only have time, unfortunately, for one more question, so I'm going to go to the other microphone, but then ask anyone else who has a question, please do come up afterwards, and I'm sure our panelists can stay for a couple minutes to answer one-on-one. So please, our last question.
Thank you. Yeah, my name is Rob Wilson. I'm a councillor-elect for PEO. But in my day job, I work as a consultant to the power industry, and I had a question regarding dispatchability of renewable resources. As we know, you put up a number, 7,500 megawatts installed capacity, but unlike more conventional sources, we're probably only talking that of being available maybe 30-40% of the time at max to power the grid. And also, it may not be available when we need it, so that's another issue. As a solution to this, I read recently in a journal, and this is in the American context, but they're now talking about the possibility of integrating the grid nationally so that when wind is blowing, say, on the East Coast, it's available to supply power to the West Coast and so on. So my question is, I guess really to Paul or David, what are we doing to address dispatchability issues? And secondly, are we doing anything to try to integrate our grid into neighboring states, in other words, to strengthen the interties between ourselves and, say, New York or Michigan or whatever, to tie into other sources of production when renewables may not be available?
Sure. I always have to be careful well, we always have to be careful, I think, when we talk about averages for things like wind or solar. Yes, they're available on average. Maybe the capability factor is 30% of the time. But as I mentioned at the outset, I have to balance things every minute, every second, for that matter. And sometimes that output is going to be 7,500 megawatts or thereabouts. So the dispatchability that I was talking about needing was the ability at times to be able to control that, because there'll be times when we can take 7,500 megawatts onto the system and other times when we just can't. And I need the ability to dispatch it down and then to vary it up and down as the wind permits. But sometimes it isn't there, and we do need the resources to be able to back that up as well. And we're learning. We're getting some education as to what it is that we can depend on, and we use a figure in the range of 10% for capacity that we can count on. But the point you make about the interconnected system, we are an interconnected system. We operate in an interconnected market. We're connected with our provinces to the east and the west. We're connected very strongly with our Midwest and New York, New England to the south. And really the eastern half of North America is a single system. And right now, or traditionally, we have operated that in a way as an integrated grid, but through the economic trade that takes place between various markets. In the past, that trade's always been done on an hour-by-hour basis. When we're talking about some of these new resources that have fluctuating values that actually change on much shorter time frames, the thing that we can do, and the thing that's being worked on most by myself and our counterparts, is to shorten that scheduling time. Ideally, you could look at operating the entire thing on a 5-minute basis, which is the way each of us in the Midwest or New York or ourselves operate our markets right now, dispatch on a 5-minute by 5-minute basis. Realistically, I think the first step that we've seen some jurisdictions taking where we want to move is to do it on a 15-minute basis, so that we can reschedule things every 15 minutes to take account of the fact that the wind's blowing in Michigan, but it's not blowing in Ontario, and 15 minutes later it may be the reverse. So we can actually operate much better. The notion of actually extending that way over to the West Coast, it's a pretty expensive proposition. There's some attractiveness in it, but in terms of an infrastructure investment, it's absolutely huge, and I think we can demonstrate a lot that we can do a little bit closer to home, at least on everything that's east of the Rockies first, before we go right continent-wide.
It's Paul's business. He's given you an excellent answer. I'll pull it up one or two more notches higher. The macro issue about electricity being generated in different parts of this country. Manitoba and Quebec are blessed with different hydroelectric resources than we have in Ontario. So we'd always challenged in our economic development portfolios to compare Ontario's electricity rates with Quebec and Manitoba, our sister provinces. And it's better for them to sell their electricity stateside than it is to sell it to us. If we were to build a line from Manitoba to Toronto, that'd be the equivalent of building a line from Toronto to Sarasota, Florida. So it's a long way, and there's not a lot of load usage between there and here. So we have some line challenges. Newfoundland, as they're building Lower Churchill, is very keen to sell to our market, but Quebec has some interests in any transmission that goes across their territory. They want to take their economic rent out of it. So I have heard, I'm not an expert on this, but I have heard that one of our challenges in Canada, and I defer to Paul and others who know this business better than I do, is that The National Energy Board doesn't regulate electricity lines, they regulate oil and gas lines. The provincial provincial regulators have regulated the electricity lines. So another classic Canadian example of federal-provincial relations has something to do with how we manage our distribution east-west. Economics drives our distribution north-south, but governance and policy in a federation like ours seems to govern our movement east-west. So we've got some work to do there as well.
I would just like to, again, thank the panel. I think particularly that you had the opportunity to rehearse at the Smart Grid seminar, just to make sure that you had everything polished for us. That was very thoughtful of the panel. I think the panel did a great job, and you just see the details. And my background is certainly in utilities, and just looking at all the challenges that you've got ahead, and I think we're in very good hands. So thank you very much, panelists, putting that together. A small token, we can give them a round of applause.